Good afternoon, gentlemen. We will begin our next class on boilers and boiler burners. So, in the last class, we had done till the high capacity safety valves and maintenance of safety valves, maintenance and checks of safety valves. We had completed till there. So, that particular chapter is over. So, and the next chapter which we will take up today is the boiler burner and boiler systems. Now, your boiler burners, we have three types of burners, which are mainly in use on marine boilers. And as you can see on your screen, pressure, steam atomized burners, and rotary crop. So we'll take them up one by one and see their the plus and the negative points of each of them. Firstly, we have the pressure jet burner. Here, as the name of the burner itself suggests, the fuel is atomized by the use of pressure. No pressure, this particular burner will not work. So the fuel is atomized by the use of high pressure pump forcing preheated oil through an atomizer. And the high pressure energy alone breaks up the oil into fine particles. In effect, this kind of burner, the atomizer of this burner, works pretty similar to our fuel injectors, many generator fuel injectors. Fuel injectors also, it is the pressure that works. If the high pressure does not exist, if the fuel injection pump does not develop that high pressure, of course, for our fuel injectors, we are talking about more than 250 bar, much more than that. So if in our fuel injectors that high pressure did not exist, the fuel injector will not inject. Firstly, it may not lift up, and even if it lifts at low pressure, what will it do? It will start dripping into the cylinder space, and then you will have extremely poor consumption. The same thing applies to this kind of pressure jet burner. So it has to have high pressure, and the fuel is atomized by use of the high pressure pump forcing the preheated heavy oil. The heavy oil, obviously, in its normal state at atmospheric temperature, heavy oil is very viscous. So we have to heat the heavy oil to low viscosity, depending on what the manufacturer wants. But I would assume that it will be somewhere in the region of 15 CST, give or take a little bit here and there. And then it goes through the atomizer, and the pressure energy, due to the high pressure energy, that breaks up the oil into fine particles. Now we obviously need fine particles to increase the surface area of the fuel. That means as much of the fuel should get oxidized. That means as much of the fuel should be exposed to air. In other words, oxygen, for it to oxidize and burn. Now this type of atomizer, it has got a very poor turn down ratio. We'll come back to this turn down ratio in a minute. So what does poor turn down ratio mean? That means a small drop in the atomizing pressure will result in a dramatic reduction in combustion performance. Earlier, we had given the example of a fuel injector. So even if your fuel injector has got low injection, if the fuel pump injection pressure reduces, your fuel injector will have very poor performance. So here too, a small drop in the atomizing pressure will result in a dramatic reduction in the combustion performance. And that means here too, what will happen to the fuel? The fuel, instead of getting instead of getting atomized, it will probably just start dripping, or the particles which are there, due to the low pressure, the particle size may be quite large. And if the particle size is large, that means it is not giving that much of surface area for it to burn, for it to get oxidized with the oxygen in the air. So as a end result, your combustion will not be proper. You start getting unburnt fuel, that means black smoke from your funnel, and of course, soot deposits in your furnace. So as a result, because this kind of atomizer has got this problem of a poor turn down ratio, so sometimes we will fit 2 or 3 nozzles to achieve turn down. That means we'll use one type of nozzle, one nozzle when we are using only low fire. If we are using want medium fire, that means there is a medium steam demand, then we'll use two of this kind of nozzles. And if the steam demand is very high and we require uh, a high amount of fuel to be burnt, keeping the pump pressure the same, then we'll need 3 of these nozzles. So that means we want to keep the pump pressure the same. Only thing, we send the fuel to either 1 or 2 or 3 nozzles depending on our steam demand and depending on how much consumption and therefore how much fuel we want to burn. Coming back to this turn down ratio, what does turn down ratio means? That is the performance between, say, full load and half load or low load. So, for example, the turn down ratio of the diesel engines on board, we'll just deviate a little bit just to get a better understanding of this turn down ratio. Turn down ratio of diesel engines on board, that means the turn down ratio actually of diesel engines is not very good. That means a generator, auxiliary engine which is powering an alternator, if the load on the alternator is low, what will happen to the auxiliary engine? Cylinder heads and the cylinder head valves will start getting fouled. Your exhaust manifolds inside will start getting fouled. Your turbocharger, most important, the turbine side of your turbocharger that will start getting fouled. Why? Because these diesel engines, they are designed to run at a certain load and above that. They are not designed to run at low loads or medium loads. For example, when there was a crisis, a lot of these main engines, they were doing slow steaming, but they were not doing slow steaming using the normal fuel injectors. The fuel injectors used to be fitted with something called slow speed nozzles. All of you must be aware of that. So only once we fit the slow speed nozzles onto the fuel injectors, only then the engines were able to perform satisfactorily at low load. So for example, your container vessels, instead of going at 18, 20, 22 knots, they used to come down, the speed used to be greatly reduced so that the fuel consumption greatly reduced. This is at the time of crisis, like starting from 2008, 2010 onwards. So, are not that great unless we do certain modifications to the fuel injection equipment. Our turn down ratio is pretty poor. And then if we, for example, we fit the slow speed nozzles, and then we want to start steaming at full speed, we again have to go back to our normal nozzles. So here too, the turn down ratio of these kind of your pressure jet burners is quite poor for the same reason, because it is entirely dependent on pressure. And if the pressure drops, these injectors, this is something what the inside of the burner looks like. You is along these passages at the side. You see where my pointer is, and then it comes to these swirl chambers. So these passages, these slots, tangential slots, which are cut into this and into the front of this injector or this nozzle. It causes the fuel to be coupled. That means the fuel is given a turning moment. If we can see here the tangential ports, they give the fuel a turning moment. And then due to the pressure, the fuel is thrown out. Right. The internet is acting up again. So here this fuel cone, this hollow cone of droplets, very fine droplets. Basically, I mean, we are talking about mist. This mist is just not moving, not only moving forward. It is because of these tangential ports, that is being tangential ports, which is giving the fuel a turning moment in this swirl chamber. The fuel is this hollow cone is also twisting and turning around so that the fuel mixes well with the air. Either depending on the size of the burner, you could be either using only primary air, or for bigger burners, you could be using primary and secondary air. So depending on the size of the burner and the amount of fuel that we are burning, this fuel is made to twist, not only shoot forward but also twist at the same time. So it has got a turning moment as well as a forward movement, and then it mixes that way is much better instead of it just shooting forward. That's why they have given the fuel twisting moment. Okay, change this. You would have seen this kind of nozzles. A pressure jet burner, something similar to this. This kind of nozzles you would have seen on board, especially those of you who have worked on ships with slightly bigger boilers. You would have seen this kind of nozzle on the pilot burner. The pilot burner is used to burn gas oil or MDO, and that fires the main heavy oil burner. So normally on board we would use a pilot burner to this kind of nozzle on a pilot burner. This is a filter. Inside that you have the same thing over here, and what we see over here is just the outer covering, just the outer covering over this, and this sprays a fine mist of the fuel, and the fuel is not only spraying forward, the fuel is also, because of these tangential ports, the fuel is also being given a swirling motion in this swirl chamber, and as a result the fuel is shooting forward and twisting around, and that is giving a very good combustion. So the pressure jet atomizer utilizes the supply pressure energy to atomize the fuel into a spray of finely dispersed droplets, and provided adequate fuel pressure is used. Again and again, this is they keep mentioning that the fuel pressure should be adequate. If we are talking about fuel pressure dropping, this extremely good combustion results will not be achieved. So for this, you need to have a good fuel pressure for the fuel to atomize properly. And once it atomizes properly, that means the fuel particles are broken up into very small. The fuel is broken up into very small particles, and the smaller the particle, the greater its surface area, and the greater its surface area, the better the combustion. So that figure, it showed a simple, no, sorry, not this, the next figure actually. It shows a simple burner arrangement for a boiler. So this nozzle is fitted actually over here, and this is the entire burner body. Your fuel is the high pressure fuel is being supplied from here. You can take out this burner inside outside for changing the nozzle or cleaning the nozzle, etc. And then you have to lock it in using this screw, so that any pressure, due to any pressure inside the boiler furnace, this burner body is not pushed out. And there's also a dowel locating it over here. So simple. This is a pretty simple burner arrangement for a boiler. Preheated pressurized fuel is supplied to the burner tip, which produces a cone of finely divided fuel particles that mix with the air supplied around the steel burner body into the furnace. Around this burner body, the air is also supplied along with it. So you have fuel spraying out from this tip. This is the cross section of the tip over here. You have fuel spraying out from this tip. Around that, you have primary and secondary air being supplied, and that mixes with this air and burns. The fuel valve arrangement, what is being shown here, has got a built-in safety due to its construction, in the sense that once this is pulled out, you will be unable to supply the fuel. It is impossible to remove the burner from its supporting tube unless the fuel is shut off, and this obviously greatly reduces the risk of oil spillage and fire hazard in the region of the boiler front. A lot of accidents take place in the boiler front because sometimes the purging of the furnace or the boiler has not been carried out properly, especially in earlier times. Nowadays, of course, the entire process is automatic. In earlier times, the motorman or what used to be called the boiler man, he used to manually start the blower, purge out the boiler furnace, and then with a handheld, uh, you could call that the primary burner. He used to actually have the rag tied to a long steel rod, and that he used to push inside the furnace, and then manually fire the main burner. And sometimes, if the purging of the furnace had not been carried out properly, you could get a blowback. And sometimes the blowbacks have been pretty violent and pretty injurious, to say the least. So, as a result of this, the design of this particular burner body is such that you will not be able to remove the burner or even shift the burner unless the fuel supply has been totally shut off, to rule out any fire hazard in the region of the boiler front. The fuel oil is fed into the swirl chamber by means of tangential ports in the main atomizer body, just like we saw. An air core is set up due to the vortex formed in the swirl chamber. So the secondary air or the primary air, or the primary and the secondary air, they are not just sent into the furnace just straight. They are sent through certain veins which cause the air to move in a kind of vortex. The vortex we'll come across later in this lesson. And this results in the fuel leaving the final orifice as a thin annular film. And also thin cone, like a cone, and that cone is twisting around. And this film of fuel has angular as well as axial velocity. Angular as in the sense that it is twisting in a kind of vortex. Not only the twisting, it also that means it is the axial velocity is causing it to move away from the burner and into the furnace, causing the fuel to develop into a hollow cone. as it discharges from the orifice, and then since it was mixing with mixing it there, and a source of heat is also there. Right, gentlemen, that was a pretty long stoppage. So, fuel oil at pressure of not less than 8 bar is supplied to the tangentially arranged ports, results in transfers of the pressure energy into velocity. That means kinetic energy. So that would mean the greater the pressure drop. That means the greater the pressure, the greater the pressure drop, and the greater the pressure drop, greater would be the velocity. But supply pressure of not greater should not be is not greater than 25 bar. It should be somewhere between 8 to 25 bar, because high pressure creates its own kind of problems, such as pumping or sealing problems at the outlet from the short sharp edged orifice. So we had seen that orifice. One sec. We had seen that orifice. It has got this sharp edge over there, and that edge actually mates, the swirl chamber goes and mates onto the backside of the nozzle. So there we could have sealing problems at the outlet from the short sharp edged orifice. And when we are cleaning, we should take care not to damage the orifice during the cleaning. We should also take care not to damage the slots, the tangential slots which are there. The edges should be kept as sharp as possible, and that again should not be damaged while. Just a minute. So we should not increase the pressure more than 25 bar. The turn down ratio is low. We have already seen that if you have a drop in pressure, that means the drop in performance is also pretty high. Advantage, it has got no moving parts, and hence therefore there's no possibility of seizures. So no moving parts, nothing much to uh, wear out, or no bearings, etc. to be overhauled. Is just the nozzle itself. Nozzle, when we are cleaning, we have to make sure that we do not damage the orifice, and we do not damage these tangential slots which give that the swirling motion to the fuel cone, to the fuel particle, and a pressure jet burner, especially the nozzle part, it is pretty simple, inexpensive, and robust. Not many things to go wrong over here. And the maximum throughput, because it has got its limitations, the maximum throughput is about 3,200. It does not this, so that's why we would require higher register. We'll come to the alteration in the air register for all outputs. That means whether low output, medium output, or high output with one burner, two outputs. In the air we do not need to carry out any changes. Rather, it need to be altered for. Melissa, can you hear me?
Yes, Chief. Good afternoon.
Good afternoon to you.
The network is so difficult to hear. Your voice is broken. Also, yesterday in your class, this happens the same. Maybe can you check your connection, please? Because the other classes was normal today. Thank you.
Okay, for that, unfortunately, I won't be able to check it myself. I will have to call an IT expert, and since he's not available, I will inform him. So maybe the future classes from tomorrow onwards, he can do some checks. But as of today, we'll have to. Is my voice coming broken now also?
Now it looks better, but a few times.
Sometimes it's getting broken.
Yeah, most of the time. Thank you.
Okay. And to vary the throughput, that means the fuel throughput through this kind of burner, the pressure must be altered. That means the pressure must be increased or decreased. But if the pressure is decreased, as we have seen, this results in a variation in droplet size. That means the size of the droplet, in other words, the atomization will not be that good. Size of the droplet will increase, and hence atomization and combustion will be affected. So if the atomization is poor, obviously the combustion will also be poor. So this is the result of this pressure jet burner. If we want to vary the throughput of the fuel through the burner by altering the pressure, that has a direct effect on the atomization. And then we start getting maybe complaints of black smoke from the funnel, etc., etc. The next type of burner is it's called the steam. Here we are calling it the internal mixed steam atomizer, but it is also called the steam jet, and in some other places it's also called the Y jet. Y as in XYZ, Y jet. So here this burner lens is basically consists of two concentric tubes. Two concentric tubes, and in the end you have these nozzle caps, and finally the cap nut. And the steam, this one for atomizing, it requires steam, and the steam and the fuel is supplied through these concentric tubes. The steam is supplied down the, and here drilled, so that the steam port and the fuel, they mix. So that means the steam is coming out from here and the fuel comes out from here. The steam basically is atomizing the fuel. If you can see in this, steam is coming from here, steam goes out. So all around the front of the nozzle, these kind of holes are drilled along the periphery. And then you can see the steam, the passage for the steam is initially it is less diameter. Then where it joins with the oil, the diameter is increased. The oil is coming down from here. Oil is also at a certain pressure, but the steam is at a greater pressure, and the steam basically atomizes the oil, and the steam plus oil, they are thrown out from this nozzle in a kind of spray. The steam atomizer consists of an atomizer body that has a number of discharge nozzles. These are the discharge nozzles. They are drilled all along the periphery, all along the circumference of this needle. That means in a pitch circle at the same diameter, these nozzles are there in such a way that each oil bore meets a corresponding steam bore at the point of intersection. Each oil bore meets a corresponding steam bore, and the oil and the steam mix internally to form an oil and steam emulsion at high pressure. The expansion of this mixture as it issues from the final orifice, which is here, produces a spray of finely atomized oil. So the steam comes from here. The steam is obviously at a slightly higher pressure than the oil. The steam atomizes the oil, and finally the pressure here gets converted into velocity, into kinetic energy. The pressure and energy that gets converted into kinetic energy, and the steam and the oil mixture, or steam and fuel mixture, they leave the nozzle at high velocity. And the expansion of this mixture as it issues from the final orifice produces a spray of finely atomized oil. Oil burners with this internal mix, internal mix steam atomizing, are tolerant to viscosity changes, as opposed to a pressure jet burner, where pressure or viscosity changes have got a very direct and I would say undesirable effect on the atomizing. Here, this kind of steam atomizing burner, steam atomizing nozzle, it is more tolerant to viscosity changes. In addition to this advantage, the steam atomized oil burners have a better turn down ratio, and they do not require a high pressure fuel pump. And also the amount of steam required is very little, especially in the modern burners. The amount of steam that we need is very little. So if we are thinking that we lose a lot of boiler water in this kind of nozzles, that is not the case. Dependent on the pressure of the oil. We have more, and the steam is basically used to kind of shred the oil into. The turn down ratio obviously is much better. That means we can okay. We start again. We were referring to these kind of atomizers as the steam jet, and here as we said, it's being called the internal mix steam atomizer, but they also call the steam just the steam jet, or it's the Y jet. Why is it called the Y jet? Because the point at which the steam and the fuel the bores they meet, and then they go further to the atomizer. That place is shaped like a Y, like as in XYZ. So the YJet system uses a separate atomizing fluid, and the fluid is steam. Steam is the usual choice when available, although when lighting up, let's say your boiler is cold and you're lighting up for the first time, you can use compressed air. Compressed air is obviously available or on board. So instead of the steam, there is also a compressed air connection, and you can use that also. Steam at approximately 10 bar is used with a maximum oil pressure of 20 bar. So you can see the steam demand is not very high, and the maximum oil pressure is 20 bar. That means from 20 bar you can keep varying the oil pressure and as per the steam demand of the boiler, and then as a result, the turn down ratio of your boiler is much greater in this case. The steam and the fuel mix within the atomizer just prior to the point of discharge, where the energy released by the steam shears the fuel into an extremely fine mist. So the pressure of the steam is converted into velocity, and this velocity it shreds actually, shears or shreds or basically tears up the fuel into an extremely fine mist. And this provides a simple system with no moving parts. Here too, just like in your pressure jet, there are no moving parts. So there's not very many things that can go wrong. An operation with a constant steam pressure and a varying oil pressure gives adequate turn-down with high quality atomization. So basically the pressure of the steam need not be altered. Pressure of the steam can be steady at your 10 bar. Maybe your boiler is producing more than that, but you use a reducing valve and the pressure of the steam can be steady at your 10 bar, and your fuel pressure can keep going up and down. maximum here it says maximum 20 bar, but you can come down to 15, maybe come down to 10, depending on the amount of fuel which you want to burn, which again depends on the amount of steam that you want to produce. So operation with a constant steam pressure and varying oil pressure gives adequate and a good turn down with high quality atomization necessary for complete combustion of the heavy fuel oil with minimum of excess air. Now, what does he mean by minimum of excess air? The more air we supply, the amount of air which we supply has to be just adequate for the amount of fuel to be burnt, maybe slightly in excess. If we supply excess air, the excess air will tend to cause cooling of the flame, and that is something we don't want. It can cause cooling of the flame, it can cause cooling of the fuel also. And obviously that will have detrimental effect on the combustion quality, and that is something we don't want. So the amount of air which we use here is just minimum amount of air that we can use, because it has got a very good turnabout, the bare minimum. And this is a system where this is one system where of a steam jet burner. So you can see that it has got internal and outer bores. They are basically two concentric tubes, and the concentric tubes, atomizer outer barrel body, atomizer inner barrel body 6 and 7, and then you have the cap nut at the end, and then you have the Y kind of configuration over here where the steam is going and meeting the oil. The steam comes from the inside, and the oil goes from the outside this space, and then the steam actually shreds the oil or shears off the oil due to its pressure, and then it gets atomized. So this is one of the from one of the makers. This is what a burner body using this kind of nozzle would look like. And we go back to our original advantages of steam assisted are greatly reduced. Hence, soot blowing and water washing of the gas surfaces need not be carried out as frequently as before. So because here the atomization is being done with a just about here, because proper atomization is being done, so your combustion quality here is very good. And since the combustion quality is very good, your deposits are, again, are greatly reduced. That means you don't have too much of unburnt fuel. Unburnt fuel, we are talking of carbon and soot deposits, and hence soot blowing and water washing of the gas surfaces need not be carried out as frequently as before. Here they are saying 18 months or more, but I think 18 months is pushing it a bit. We normally would like to do much more frequent soot blowing and water washing of the gas site surfaces. But you get the idea that here, since the atomization due to the design is so much better, and the turn down ratio is so much better, so then as a result your deposits or unburnt fuel is deposits, soot, etc., due to unburnt fuel is also greatly reduced. So your demand for soot blowing and water washing, etc., your maintenance demands is also greatly reduced. And this is because of point number 2, that the atomization and hence the combustion is greatly improved. Number 3, percentage CO2 reading is increased. Oxygen reading has been lowered to 1% or below, hence boiler efficiency is greatly improved. Percentage CO2 used for producing inert gas. It's not necessary that the exhaust from these boilers is just going off and getting wasted in the funnel. So some of it could be Some of these boilers could be the flue from the exhaust flue from some of these boilers could be used to for inert gas, for producing inert gas. So for producing inert gas, obviously percentage CO2 reading should be very good. The percentage CO2 means you should have least amount of carbon monoxide, CO. Carbon monoxide means the combustion has not taken. As we it is given as excellent over a wide range to one. So that means it's a pretty good ratio. That means that as an example, at boiler could be producing say 20,000 kg per hour of steam, and then in the load, the wide range of loads because of this burner is quite excellent. And coming back to point number 3 again, since your boiler, the atomization and the combustion is so much better, your the refractory problems due to unburned fuel, that will also be reduced. We should we have is due to unburned fuel. There's some unburned fuel is landing on the refractory. It is burning locally over there. It's getting carbonized, etc. So the longevity of your refractory, that is your fire bricks and your longevity of your fire bricks and your fire clay inside furnace, and also around the around the burner, burner And in the event of, okay, we'll start again. In the event of steam supply failing, the burner can be easily reverted to the pressure jet principle. If the steam supply fails, not only should we, not only can we use air, we can also revert it back to the pressure jet principle, and then, I mean, it works as like the previous kind of nozzle that we saw. A steam control valve may be fitted to reduce the steam pressure low loads. And then we we have talked about the advantages and then we come to the next type, rotary cup burner. This is the one that is quite widely used, and especially on tankers, you will find a lot of this boilers, this kind of burner. So basically, this as the name
Not hear you at all.
here, okay, start again. Here we are talking about rotating oil burner, and the cup inside the rotating oil burner that atomizes the oil by throwing it off the and at high speed. He's talking about RPM. Now how this works, we will see in the diagram. The basic figure shown in 16.23 consists of a tapered cup. So you have your spinning cup over here, and the cup is fitted onto the end of a rotating spindle. The spindle is being rotated at a high speed of 2000 to 7000 RPM by this electric motor via this belt. And the spindle is obviously it's mounted on bearings, roller or ball bearings. The fuel is applied to the inner surface of this spinning cup, so that you have heated fuel. Most of the time we are burning fuel oil, so you have heated fuel oil being supplied to the inside of this cup at a very high speed. This fuel starts going towards the edge, because whatever fuel is there, firstly due to centrifugal force that is being pushed into the onto the greater diameter of this cup, and also since new fuel is being fresh fuel is being supplied all the time. So somebody said something. Because fresh fuel is being supplied all the time to the inside of this cup. Well, gentlemen, it seems particularly bad today. I don't know for what reason. So here the centrifugal force causes it to spread out evenly into a thin film, which then moves out along the taper until it reaches the lip of the cup. And once it reaches the lip of
Chief,
the cup,
Chief,
due to the radially acting
Chief,
forces,
Chief, we are not hearing you. Please, Chief.
Chief, can you hear me?
that causes it to break up
Chief, Chief,
into
Hello, Chief.
the
Chief.
surrounding air stream.
Hello, Chief.
So the fuel is basically thrown off from the end of this cup, and that is how
Chief.
it is atomized. Remember that this cup is being spun at a very high speed. Yeah, go ahead, please.
We cannot hear
Yeah, I can hear you.
at all, Chief. Do something. We cannot continue like this. It's totally. Please do something. We cannot continue like this.
You-
Not hearing nothing, Chief. We are just sitting.
yeah, I can hear you now. Yeah, I can hear you. I can hear you.
We cannot
You cannot
do
hear me.
anything you say.
Hello.
We cannot hear whatever
Hello.
you say. No, we cannot hear you, Chief. Yes, can you hear me? We cannot like this.